Hello everyone, my name is Amanda Sourbeer of Wade Trim. I will be going through a demonstration on how to set up and run the design storm for the POC submodel. For this demonstration, we will be going over the two-year design storm, since that's the design storm that the SSO communities will need to run for their consent order. If for some reason you're looking to stress the system with a larger design storm, you can follow the same steps here. You will just need different boundary conditions that Three Rivers can work to provide for you. So just a brief review on how to do that in PC Swim and EPA Swim. We're first going to save the model as a new file, reference the two-year design storm file in the rain gauge table, and remove the typical year rainfall file. We're going to change the boundary conditions to reference the two-year design storm boundary conditions. The ones you have received from Three Rivers represent the typical year conditions in the system-wide model. We'll have to change those out for the two-year design storm. And if running a winter design storm, the climate file will also have to reference the modified climate file. This climate file changes out some of the temperatures in the winter period that we will be running for the design storm to ensure that any precipitation that fell during that period is treated as rainfall, not snow. It also would impact evaporation and such. So make sure you run the modified climate file when running the design storm. Next, depending on whether you're running the summer design storm or the winter design storm, we've selected these periods. Actually, I think it was selected by Alcasan. These periods were selected because this was during the dry weather flow period. So we have, we're starting off with a smaller flow in the system for that season. And it's just a 7-day period of dry weather flow. If changes were made to the model, you'll want to create a new hot start file. Typically, if any changes were made, the program, I think both EPA Swim and PC Swim may throw up an error message indicating that the hot start file can't be used, so a new one have to be created. This is done to start off with some flow in the system. You're not starting off with dry pipes, which can lead to instabilities. And then you're ready to run it. So let me get started with the demonstration. I will start with the PC Swim model. I like to create a copy of the input file. You could also, if you want, save as, if you already have a typical year model file, and then just make sure you're changing the name from TY to, for our demo, we're going to be running the Winter Design Storm 2-year. So I like using the initials WDST2YR. And then you can open it up in PC Swim. Now, when you're first opening up an input file, PC Swim will default to the latest swim engine available. Alcasan hasn't yet vetted any swim engines beyond 5.1.012. So for our purposes, we're going to stick with that engine, change it to 5.1.012. You can save it here. And next, we're going to change out the rainfall file with the 2-year design storm. We reference the 2-year design storm in the rain gauges tab. You click this table icon to bring up the rain gauge table. We're going to bring the file path of our winter design storm into that cell, which I will navigate to here. I bring it up here to be able to copy out the entire path with the file name. Now that I have that copied, I'm going to paste. Sometimes it takes 2 clicks to do it. Now that this cell is referencing the 2-year design storm, I'm going to copy this cell, click the header file name. That'll select all 102 rain gauges. And then you can hit paste to apply that to all 102 rain gauges. Next, we're going to change out the station ID. This station ID is actually referring to the first column in the rainfall file, which you can open up in any text editor. You can see here it's applying to this WDS2 year. So we need to replace what we have for the typical year with this WDS2 year. Copy, exit that out for now. Paste that in. Select the station ID to highlight the entire column. Paste to apply to the entire column. You see that's being applied correctly. The next thing we need to do is change out the time series. Right now we're using time series that reflect typical year conditions in the system-wide model. We have 2 sets of the time series we need to replace. One would be the downstream head time series. This is referenced at the most downstream outfall. I can show you down here. This is where our submodel would connect to the rest of the system along the interceptor. So this head time series is representing the interceptor levels at this location for the typical year. So we'll need to replace that with the levels for the 2-year design storm, which is provided to each municipality. There's also, in some cases, in this case, we have 2 upstream boundary conditions that need to be replaced, one at each of these nodes here. These represent flows that are coming into the system that have been cut off from this submodel to allow it to run faster. So we have 3 time series that need to be replaced. This other time series is just representing the river boundary condition or the river levels for the typical year. We are going to leave this the same. We're still running, for the design storms, we're just running a certain period in a typical year. So we still want to use that boundary condition file. Let's go ahead and replace this. Instead of going through the model and identifying where those boundary conditions are loaded into and changing it from here, if you're changing it here, it will update within the model automatically. And I'll show that to you. So I can change this to WDS2 year. So we're no longer referencing, we're not going to be referencing the typical year. We're going to reference the Winter Design Storm 2-year flows. I'm going to copy that to make it easier. Here we're going to change this out from a typical year to the 2-year design storm. And make sure you're using the file with a similar name, which starts with the element ID that the time series was extracted from. So it's LBS 1291896. Open. We see that's referencing it. Hit OK. Let's do the same thing for these other time series. Then we have one more. Just to double check that we've applied the RunningDesignStorm flows. Hit OK. You can see that this the reference time series at the downstream outfall here has changed from that typical year head time series to the RunningDesignStorm time series. You can also check up here at the upstream boundary conditions. Okay, so we've referenced the 2-year design storm, referenced the 2-year boundary conditions. The next thing we need to do is set up change out the simulation options. We're going to change the start date for RunningDesignStorm. We're going to use January 18th. Oops. January 26th, 2003. And here in the Files tab, we're going to remove the rainfall file. This is the typical year rainfall file. If we left this in here, it would result in an error trying to run it because the rain gauges, if you remember, we changed the station ID from the typical year pixel IDs to WDS or SDS 2-year. It's going to look for those station IDs, and that's not going to appear in this rainfall file. I think it would normally supersede what's in the rain gauge table. So we're going to remove this to make sure it references the 2-year rainfall file. We're keeping the inflows the same. The hot start file, I'm leaving the same because I didn't make any changes to the model. Hit OK. Oh, the other thing we need to do, because we're running the RunningDesignStorm, is change out the climate file. It's currently referencing the existing conditions, typical year climate file. We need to change that out and reference the modified climate file for the RunningDesignStorms. And again, this will have modified temperatures for the month of January to ensure that any precip that falls is treated as rainfall and not snowfall. Hit OK. And we should be good to run. I'm going to allow this to run through the whole thing just to show you how quick it is. It's a lot faster than a typical year simulation. Okay. So we see that the run was successful. And one thing we could check, you go into the status tab, you could just hit the routing button down here, or go into the status tab and go into continuity errors. Here I'll summarize some of the simulation results for you. So we have total precipitation here as 1.64 inches. And if you go back to the PowerPoint that we presented, just to confirm, that is the RunningDesignStorm precipitation volume. We see that the rainfall was at least referenced correctly. And that's it. I will switch over now to EPA swim. I guess before I open the model up, I'm going to create a copy of the model file, the input file, do the same thing, change the TY to WDS 2-year. Now I'm going to open up the input file here. Just briefly, and then we're going to close out of it. So we're going to do some of the changes to the rainfall file directly in the input file. But for now, I want to show you why that is. So in order to change out the rainfall file and reference the 2-year design storm, there are 102 rain gauges here. Again, I'm not I don't use EPA Swim regularly at in my job. I usually use PC Swim. So if there's a better way, there may be a better way to do this, but I've only been able to directly in EPA Swim. I've only been able to change their rainfall file individually. So to open each one, reference the 2-year design storm, change the station ID, and you'd have to do that to all 102 rain gauges. The more efficient way that I've found is to make that change directly in the input file. So I'm going to close out of this for now. I will open up this in an input in a text editor. Navigate to the rain gauges section. Here I'm going to copy out all the data underneath the headings. Copy. I'll open up the spreadsheet. Paste. And here you need to go into data, convert it from text to columns. Right now it's all in one column, and you're gonna have to separate it out. You want it in different separate columns. I'm gonna use the text to columns tool, delimited, use a space as a delimiter, hit finish. And here I'm going to replace this path with the path for our 2-year winter design storm. We'll copy this, paste it into here. And I do think that, especially if you have any spaces in your path name, I do think it may require these open and close quotes before and after your file path. And then you can copy and paste down the column. And again, change out the station ID with WDS 2-year or it's SDS 2-year. If you're running a different design storm, open up the rainfall file in a text editor and just make sure you're referencing whatever that first column says. In the 2-year winter design storms that we're providing, it'll either be WDS 2-year or SDS 2-year. And then we're going to copy this back out and paste it directly into the input file. So I already have all this selected. Oops. I'll select that again. Paste will replace it. The formatting is going to look a little different, but EPA Swim will see it the same. I'm going to close out of it and save. And then I'm going to open up EPA Swim again. And we'll open up the 2-year file. And I'll show you how to check to make sure that the 2-year was applied correctly. So yeah, the first rain gauge referencing that 2-year file. Station ID it's referencing is the WDS 2-year. Check this one. Yep, that one's referencing the correct path and the station ID. Next thing we want to do is change out the time series. Um, so in your submodels, you'll just have a few of these. I think it's easy enough to do directly in EPA Swim. I'm going to click on each one. Again, changes from TY to WDS 2-year. Change the external file referenced to the same name with the WDS 2-year at the end. Well, okay. Okay, M61. RBC is the river levels that we do not want changed. We'll skip that. Move on to T07. And okay, one thing I forgot to mention, if for some reason the references, say you're looking at this outfall, if for some reason the time series is no longer connected, and you're just having trouble figuring out where your boundary conditions should be applied, we will provide this table for each POC submodel. We list the boundary condition element, the non-river boundary condition element that was exported from the system-wide model. Will indicate if it's a link or a node and the type of time series. It'll be either flow or head time series, and the submodel node that is to be applied. So for the most part, the most downstream boundary condition, which is a head time series, that'll have the same name as the element that it was pulled from, but the flows coming into some of the submodels, that's being pulled from a link and it's being applied to a node in the submodel. So that may very well have a different name. So this time series will be applied to this node here. We can check this here. You zoom in the upper limits of the submodel. Yeah, you can see this node is referencing the 1291896 time series. Yeah, so instead of going into the map to change out the inflows, at least in EPA Swim, it is easier to just do that directly in the time series and it'll be applied into the map. You see that's referencing the RunningDesignStorm 2-year time series now. Next thing we want to do is change out the climate file again. We want to change it to the modified climate file. And then change the simulation start and end date from January 1st to January 18th. The end date would be January 26th. In EPA Swim, you have to manually change the start reporting date. Okay. And then we're going to remove the typical year rainfall. Okay. Now it should be good to run. We'll run simulation. That looked like it ran into an error here. Oh, nope. Okay, it was successful. Now, if we want to double check the precip, you can go into the status report here. Let's see. I don't know if there's a way to search. Scroll all the way down. You can also open up this RPT file directly in the text editor. There we go. We see that it applied a 1.64 inches of rain. If you have any questions on how to do any of this, if you run into any issues, make sure to reach out to Three Rivers, and we can have either me or somebody reach out to you to help you resolve some of the issues you may be having. Thanks.